All right. I think we're ready to start. Are you guys ready to start?
Whoever's presenting with me just went to the bathroom.
Okay. We'll give him a minute. Just start the stopwatch. Where are we? 10 presentations. Fresh. Hey, group one, did you upload your presentation?
I don't know if we did.
You didn't do it successfully. You tried.
Yeah, I'll put it down my Wi-Fi.
All right, if that's not going to work, just figure out how to get it presented. You also, so you have a presentation for you guys. All right, you just hit refresh. It should go up. The little, yeah, there.
I don't know why the keyboard. There you go. Good to go, Professor. Professor, we good? All right. Morning, everybody. So we're Team 1, the Can Crusher team. So just want to go over our week's progress this week. We prepared a list of our stock material that we needed along with a cost sheet. We also prepared a list of hardware that we see that we'll need when assembling our project. And then we tried to get our simulations, our camp simulations, but we kind of had trouble just due to our experience, and definitely need some help with it. But we tried with 3 SolidWorks cam, and then also Fusion 360. And then, so for our goals for next week is to finalize those simulations and tool paths. So we're a little bit further behind than we'd like to be. And then also for next week, we want to machine at least 1 or 2 of the simpler parts that we have, you know, and get the ball rolling with that. Again, some of our problems and challenges that we had this week is difficulty relearning a spree. A lot of us took it our freshman year. So trying to go back to the ME1800 website and trying to relearn it has been kind of a struggle for us, and it took us a little bit too long to ask for help, I think, but hopefully we'll get moving with that next week. And then to go off that, we are meeting with Hayden to try and go over and relearn a spree with a little bit of guidance. So scheduling, I believe we're in about week 4. So we're still in our CNC program preparation. And then towards the end of this week, we should be able to start machining parts. I'm sure we're gonna have problems with that, but our schedule, we should be able to finish and get everything done on time. So this is a list of the stock that we need, along with prices. Some of the stock was a little bit on McMaster anyway. When we looked, it wasn't quite the exact specification that we saw we needed, so we couldn't get a price on that. So we might either bump it up to the next biggest size. But yeah, I guess I won't go through every single thing.
Yeah.
But what we were kind of considering was for the body wall. For the body walls and everything for the body of the can crusher, it's all going to be the same thickness stock. So we're thinking about maybe just getting a longer piece of that stock and cutting into the sections that we need. It might save money in the long run instead of buying these smaller individual pieces. But that's something we're going to still need to calculate once we have everything finalized.
Yeah, that 1692 should be for body sidewall and body floor pieces as well. We just figured we'd explain it. For the total hardware, we don't have much. 1/4-inch hex bolt, 3/8/16 socket head screw, and a 3/8/16 hex nut. If we need to add anything else, if we see any other spots where we'll need hardware, obviously we'll update this, but yeah. And then we kind of got our feeds and speeds kind of somewhat ready, as you can see here.
Yes, so these are some of our most common tools that we saw that we need for the parts that we're making.
And a couple of us were able to get our CAM software to run. Here's one example of the sliding jaw. This is the part that will actually crush the can within the body.
So again, like we already kind of talked about, our next steps is to finalize our simulations and tool paths. Meet with Hayden to really solidify our understanding of the spree and CAM, just so we have the confidence to make the decisions we have to. We want to begin to start ordering our stock material and hardware, and then officially finalize any design changes that we have to. And then again, we want to have 1 to 2 of the simpler parts ready for next week. And yeah, that's our plan so far for the coming week. Any questions, suggestions, comments?
Feedback from the class.
Yeah.
In terms of feedback, I would just suggest a few more visuals. I think that might be useful for the audience.
Okay.
Anything else? Could you go back to the slide where you had the simulation? Could you talk us through the operations here and what the tooling is? Because it's hard to see it on the video.
Yeah, so this actually is neither of our, or is this yours?
So do you know how tall is that part? How deep does that mill that goes around the side, how deep does it go?
So that would be the sliding jaw. So it's 3x3x6. 6 inches wide, 3 inches tall, and 3 inches deep. So
Okay. Yeah, just because there's no scale in the picture,
Yeah.
it's hard to tell
Yeah,
how big things are, how long the tool is and stuff. You can't pause this, can you? It just repeats.
I don't think I can.
No. Okay, that's all right. We can just let it repeat here. So comments from the class on the tool path. Any feedback? Yeah.
So looking at the simulation, I'm curious. Maybe it's like you just want to double check after it runs through.
So it faces off, it contours around, and then it does this open pocket.
And I think we flipped 180.
I guess I just wanted to take a look because to me it looked like it was cutting a little too deep too quickly. It just is. How deep is the increment?
I don't know. That's a total of 3 inches tall.
Right.
So I'm guessing they're going 1.5 inches deep.
4.
So 4 divided by 1.5.
Okay. Just something I was thinking about. Just because it
That's-
break the tools if it's too
That's
much.
probably okay. It's, I would worry about that corner there. So when you go along the side and when you go along the back, I assume it's about the same thickness as the side. When you get to that corner and it dives into the corner, it's going to suddenly see a much higher force, a much higher load on the tool. And so I might be a little bit concerned about diving into that corner because you load up pretty much 100% of the tool just instantaneously around the corner there. That could be an issue. It might be fine. That really depends on the tool. And so that's 1.5 inches deep. And I'm guessing then based on that scale, it's probably 1/2 inch or 3/8 inch channel.
Yeah.
So you could probably do that. I'm looking specifically at that open pocket on the back of the part here that's facing us.
Yep.
So anybody in the class have some feedback or a better way to make that open pocket?
I think he has.
Yeah.
So I was just thinking about how many operations this part would take, like the current way that you're machining it. I think it's 3 because you have those holes in the side. You'd have to flip it once to eliminate your raft and then also get the holes. But I think depending on how much you care about that bottom surface, the bottom as in that like face we can't really see.
Yeah.
Back there. Depending on how much you care about that, I think you could do the operation in 2 by rotating your part 90 degrees upright and machining that pocket like top down,
Yeah.
and then flipping it once to do the holes.
I would do the holes first also, if you do that. Just because when you've got that, basically you've got a horseshoe that is drilling a hole from one side to the other. And so the top side would have flat push on it. And then when the drill gets through and it goes through air to the other side, when the drill comes in contact on the other side, the drill's going to want to walk out also. So if you follow his advice to do it that other way, drill the hole first. The other thing I'm thinking here is, so you see what it's doing here is plunging down into the material. And it totally could enter from the outside.
Yeah.
So the program you've got here is a contour. I think it's just doing a contour all the way around.
Yeah.
If you broke that up into 2 different operations, for the thing that is that slot, you can do an open pocketing operation. So you define that one side as an open edge, and then the tool will enter from outside. And so that would reduce the need to plunge down the part.
Yeah.
And so with this process here, and so I'm using your part as an example, but I'm talking to the whole class, right? So with this process here, also what I see is you're going to then flip it over and do a similar process on the other side.
Yeah, I think it's identical.
And so that's possible. The trouble is when you flip it over, you're not going to have a surface to locate from necessarily that's a square surface. And so getting those 2 operations to line up with each other without an offset could be an issue. It's certainly possible to do. I've done it hundreds of times where we flip the part over and you get it aligned. You often see a line where there's just a little bit of a mismatch there that doesn't affect function and stuff. But that's something to consider with the other method that was discussed. You wouldn't have that same issue. I think you might, if you did need to have that fillet on the back corners, you might actually need to still put it in 3 times.
Yeah, I think the reason why the part is situated as it is because the side that we see, this side, is what you you won't see, so that faces down. So
Yeah.
you'll see all of this up top. So I think we wanted to get the top as pretty and as nice as possible, just for visual.
Yeah, so those are all things that it's sort of up to you as per.
Yeah.
I just want to give some feedback. I would definitely do the open pocket.
Yep.
And
Both first.
I think, anybody remember what chapter the open pocket's from in the instructions during the tutorials? I think it's chapter 4, where we talk about how to create an open pocket. But basically, what you do is the chain that defines the pocket if you've got highlight and sub elements turned on, you click on it and then you right click to say, no, this isn't the thing I want. And you do that up until you get to the chain so that's the chain you actually want, right? But you still say no there, and then the next thing that comes up is the element of the chain that you clicked on. So then you can highlight that element only, and if you go to properties, you can say open edge. And then actually you'd have to make that a separate chain that defines the pocket to do that. But that would allow you to do that. So it's like a pro tip. I would definitely do open pocket so it doesn't have to plunge inside the part. And you see it's leaving that little bit of material in the back
On the
there.
corner.
So it's taking off more material on the side that's away from us
Yeah.
than it is on the side that's facing us. And so you can change that by shifting your part over in the stock material.
Yeah. Okay.
But typically we don't like to leave that little bit sticking out like that.
Yeah.
It's, again, you're 100% loading the tool when it goes into the corner. And the other thing is that little bit, eventually what connects it to the workpiece material is going to not be as strong as the cutting force. And that little piece is going to fly across the machine. Probably won't hurt anything. But if you do it just right, it could like break the tip off the probe or something like that.
Yeah, I
I've
think
never seen it happen, but physics
Always
says
the
that it's
first.
possible.
it's always the first.
Spoken into existence.
Yeah, I think like just like stuff like this, like
Yeah.
shifting the part over in the stock. This is the kind of stuff that we've been struggling with. Like
Yeah,
just
that-
basically the
It just takes
fundamental.
some practice.
Exactly.
And I think, I mean, it's tough for all of you to sit in a room and do it at the same time
Yeah.
together, right? But if you do it with more than one person,
Yeah.
even working on different parts, then when you get stuck on something, you can talk to each other and maybe start
Yeah.
seeing that you work past it. That seems to work pretty well. So if you can time it where you can all go to the computer lab at the same time, that's a good idea.
Yeah.
I get with scheduling, that's tough to do. But I think, so not only, I mean, you can use the tutorials that we have and stuff, right? But you can also say, I want to make an open pocket, it's free, and just Google that phrase. And you're going to find probably a YouTube video of somebody explaining how to make that open pocket. There's plenty of content out there. And you mentioned also at the beginning that you were trying to do it in 3 different CAM packages.
Yeah. Well,
Is that because of different people?
I think that was just because we were having so much trouble with the spray. We were like, oh,
Yeah.
maybe SolidWorks CAM will be better, and then SolidWorks
Yeah.
CAM wasn't better, and
I-
then tried
and
to use 360, and that wasn't better.
So if you've got unlimited time, this wasn't the class where I drew the graph about time and motivation, right? That was
No.
my other class. I have these 2 classes this term, so I get confused about which one. But if you think about it, if you have, you guys can sit down. I think unless there's more stuff from the class. But if you think about it, if you've got unlimited amount of time and you've got a hard task to do, even if you don't know how to do that task, if you've got unlimited time, you have basically infinite ability because you have a chance to learn how to do that task. As time compresses, as you get less and less time, the apparent skill level, so that's like your actual skill plus your ability to learn, your apparent skill level comes down because you have less and less time to learn stuff. Eventually, there's no time to learn it just based on what you already know, and that's what your apparent skill level equals your actual skill. So if you think about the axis where you've got so time on the horizontal axis, and on the vertical axis, you've got apparent skill level. But you can put another axis up there that says motivation, right? And so when you've got a project and you've got unlimited amount of time to do it, you have pretty low motivation to work on it. as the time gets closer, the motivation skyrockets, right? So you can imagine parabolic curves that cross each other, right? Motivation's going up as you get to the time, and the skill level's going down as you get to the time. And so I worry about that moment where the two graphs cross. I jokingly call it, right? That's when motivation has become desperation, right? Because the skill level's falling really fast. And actually, as you get really close to the deadline, if you're really far behind, you make stupid decisions. And we've all done it, right? Yeah, so, anyways, so I would pick one. It doesn't matter which one. I would pick one and focus on that one rather than trying to see if another one's going to be easier. That's my advice.
Okay.
Group 2, you guys ready?
Appreciate it. Thank you.
And Joseph?
Thanks.
Group 2, 920. Oh, right on time. First time ever that we had a group and right at the moment. Good job, group 1. And you're welcome for that. What do you mean I don't have permission for this presentation? That's probably one of the videos I have. Well, we'll see. You can, if you want to log into Google this.
Where do I log in?
I think it's just in the browser if you
That's
log
what
into
we
your
shared
video, right?
with you too last night. This one. Oh, okay. How do I sign up? Oops. That's funny. I was really mad yesterday because somebody had borrowed this cable and not returned it from the place where it's supposed to be. It was you. I am certain that I remember having returned it after I borrowed it. Somebody must have snuck in after I was done and put it back in my bag. That seems the most likely. That's what happened, right? Yeah, totally. Was it you? You know, lightning cords all the time. Okay, so. I'm still certain I'll make a change. If I'm really mad, I suppose the more accurate description would be mildly annoyed. Okay, I think we're good to go. Lovely. All right, so we're group 2. I'm David.
I'm Grace.
No, Shane. This is just our CAD models we've seen previously.
So this week, we got to Jackson, and David and I went to the lab yesterday together, and we worked on the spray. Jackson got really far in his pond. I don't know if he included like a simulation, but but probably because we still need to work on it. I think something like there's like a collision or something like that. But yeah, those got started this week. So.
Yeah, I actually included my simulation. I finished what I have up last night. I'll play the video, but before I do, just like some of the things that I'm having trouble with currently is the left-handed roughing pass, like takes off barely any material, but it does like a lot of passes toward the part and it doesn't actually cut much. So I'm wondering if maybe I can just skip the roughing pass and just go to a finishing pass on it. The finishing passes themselves still need a little bit more fine tuning, just because I'm a perfectionist and I want to get it as close to what the part I want the part to actually look like. And then finally, There still needs to be a milling operation on the front end of the king before it's like ready to go into the machine. This is what it looks like. I'm gonna go full screen. Nope. So it does its facing pass here, and then I used a grooving operation here to cut out the little crown shape at the front. And then it does roughing passes with a right hand 55-degree bit. And then it'll come back with a 35-degree bit and do a finishing pass. And then same, this is the left hand roughing pass I was talking about. That just like kind of does nothing. That comes in, and then we cut it off. So that's that. And then the next slide. Nope, that's not what I wanted to do. How do I go to the next slide? So I talked about this with Professor Bergstrom in the lab yesterday, and I meant to research more into this process, and then I didn't have time. But he wanted me to bring it up regardless, so we could talk about it as a class. But I found this video on like a pretty cool way that they were machining these chess pieces, and I don't know. I just thought it was pretty cool. So I don't know if we want to talk about it now or at the end. Sounds like at the end.
So some of the problems and challenges our team has had, obviously, a lot of our team is pretty new to things. So our team has some very limited experience, coding the turning parts in Esprit. And then there was initially Jackson actually had a big problem downloading Esprit on his computer. He had to download and uninstall it and reinstall it 3 or 4 times. It was a little bit of a mess, but
Eventually he did.
he eventually did in fact get it. So finally cooperated with him.
Yeah, so for our assistants and opinions, we have just to schedule more appointments to go over code with the professor, and just make sure that we, get all the code for all the parts situated. And then goals for next week is just hopefully having completed the code for more than just the king, and hopefully for all of them. And then to have, I think the whole team is basic internet users. If not, maybe 1 or 2 still have to do it, but just getting that completed is also a goal for next week. And then, having made a piece by early next week or by the end of this week is also one of our goals. So probably pretty feasible. So
One more slide.
So does anyone have any questions, comments, feedback?
Those little bits on the end that you leave off with your pieces, is there gonna be could there be a potential that could get cut off from the rolling force, or
Oh,
one machine?
oops. So you're talking about that bit. I guess we won't know until we put it in a lathe. I'm making sure to do my best to avoid crashes.
Video again, the beginning part of the video. You go ahead and pause the video. So the nice thing about the way they're doing it here in this particular cutting path, because that is an issue, and it totally could happen. But so with the way he's doing this cutting path here, it's pretty small cutting force. He's making a really small chip. So, and he's only making that at the small surface, he's only making a chip there for an instant. And then he moves over to where it's a big, thick surface. So it's being supported very close to where he's cutting, which is one of the reasons that this tool path makes it a little bit easier to make that small diameter. The other thing you could do if you're doing like a regular turning operation and you just needed to make a really small diameter there is you can actually have your tool path be at a 45-degree angle. So you gradually come down to that slope, and so you can have it rough the material away in little 45-degree chunks, and so you're only at that small diameter for the last part of the cut. So that's another way to do it, but yeah. But that was a valid question, because it totally could be too much cutting boards and break that off.
Because I didn't know.
You'll know when you put it in the lathe and try it, and if it is, then you'll reduce the step over, or
I already did. I
reduce
think,
the step over, or reduce the feed to make the chip smaller.
yeah, I think it defaults to 50% step over, and I think I brought it already down to 35.
It looks, from the simulation, it looks to me like it'll work, but it might not. And so you were thinking to mill it before putting it in the lathe?
No, after.
Okay. Because that would be another way to do it, would be to mill the two flats for the tip here, and then put it in the lathe. So make the top part skinny. But I think then with the interrupted cut coming around, then you're more likely to break the piece off.
And then you had also mentioned that there's, like, right now this is just like the default grooving tool that was in the
we might be able to use a different grooving tool.
Yeah, I think you had mentioned some that have not like a rounded edge, and maybe have like.
I think the rounded edge is good for you. I mean, you'd like to have a square corner inside. Is that what you're saying?
If I can't,
This
you know,
reduces
I
stress
don't care.
concentrations.
Okay.
A little rounded on the end.
Yeah.
And you don't need the roughing pass with the other handed tool.
Okay.
With the left-handed tool, you can just do the contour.
Okay.
Anything else from the class?
I just have a question for like general, that's great. When they have like this first operation for this is the king, so
Yeah.
when you put that into the mill and you have to do that simulation or that, will it start by showing like how can you put into.
Yeah, so when you finish, so if you, and even like the last one, right, where they were gonna flip the part over.
Yeah.
So you get your stock material based on whatever the stock's gonna look like. You do that simulation. When that simulation is finished, on the simulation toolbar, one of the items is save stock as STL. And so you click that, and then you can output an STL file that is what the Esprit thinks the part's gonna look like. And then you can load that in and use that as the stock for the next part. Anybody else? All right. Group three.
I wasn't sure if you wanted to talk about.
Oh, we
that.
could, yeah, go back to the other video. I had forgotten. And so this is a pretty common thing to do in production. And what they've done is they've made a form tool that is the shape of the part that they want. And they've got a progression of form tools here. So it goes across one. And so I don't know that you can see this, but that the wooden piece is rotating. Right, so that's turning on like a lathe spindle, and it's feeding across the two tools there. And so you could do that. So this particular example is with wood, but you could do the same thing with metal parts and things like that. You'd have to take smaller chips, so it might be a longer process there. And it's very common in grinding operations. So you want to make a specific shape. What you'll do is you'll form a grinding wheel to be that shape that you want. And then, like if it was a turned part like this, you'd spin the workpiece, you'd spin the grinding wheel, bring it together, and it will grind it away, and it'll make that shape all in one setup. So I just wanted to bring that up because that's not something that we talk about. It's not often with CNC machining. We don't take shortcuts like this because we could just go across and we could use our regular turning tool to make this shape. But I think we do ourselves a disservice to not think about how we can use physics to help us out. And so going back to some of these older processes and then adapting them into your CNC setups, I think can be a big help, especially to speed up production, things like that. So I just wanted to bring that up as a topic.
Thank you, Bella. I appreciate that.
Group 3.
Hello everyone, we're group 3, I'm Amber.
I'm Kyle. All right, so for this week, we made a lot of progress on the simulations and the tool paths for the wheels specifically. We also got started with a spree for the rod. And we determined some manufacturing operations that are available to us for the rest of the parts. We chose to 3D print the frame, so we're gonna be working on getting that sent through Foisey. And we also introduced ourselves a little bit to wire EDM and also how to do solid wire, which is the spree version of wire EDM simulation. For the wheel operation, as you can see here, this is our simulation for it. Unfortunately, we have no fancy video, but we'll have to make do with these images. We're going to be doing a boring operation through here, and then a series of basically packing operations through here, and finishing off about between a 55 and a 35 degree tool through here in order to do the finishing patterns.
So the best way to create some of the remaining parts for the handlebar and the linkages, we're going to drill the holes in stock on a mill, and the shapes will be cut out using the wire EDM. And then the nub that's attached to the gear that rotates the actual, like the linkage rotates the gear with it, will be 3D printed. We're working on printing the frame. The axles, bearings, and brackets will be purchased. Some issues we ran into this week when doing the esprit for the wheels, the tool path just kind of ran straight through the part. So we're working on fixing that when we run the simulation.
Group 2 knows how to solve that problem.
Okay. And then we had a little bit issues getting the parts from Fusion 360 into Esprit. And then we're not really comfortable using the wire EDM unsupervised.
Good.
Some progress that we're looking to do for next week. We want to create all the SP files for all of our parts, begin producing our parts, design any additional 3D printed parts that we need, and print all of the parts.
Does anyone have any questions? And just as a reminder, this is what we're going to be purchasing. Question?
Just out of curiosity, you picked 3D print for the frame over laser cut, like by just chance?
So while the laser cutter in Washburn and in Foisey is very large, the frame is going to be quite large, and purchasing actual wood for that rather than just 3D printing the frame out already assembled seems much simpler.
Okay.
Just 3D printing parts of the frame, that should be
3D printer.
3D printing parts of the frame, I should say.
Okay.
Yeah. Yes.
Do you guys have a model for the?
Yeah, we have a.
Put that in the presentation.
You did put on
It was in one of our last presentations.
Any other questions?
The quarter ton aluminum, what's that going to do?
We're going to try to reload them. That's for the
Axles. Okay.
And the other benefit to 3D printing the base is that there's bearing hangers that you can't laser cut because they have depth to the base. So if we can just 3D print them, then we don't have to buy a bearing hanger.
Anybody else? Can you go back to the slide with the pictures? What component is this?
this is for the wheel.
What's the pointy part? Like, looks like an arrow.
Oh, this part?
No, the shape of the finished part looks like an arrow.
Yeah, that's for the, basically because we're doing it off of a hand cart. It's kind of simulating what the wheels would look like.
Is that extra material to hold on to, or is that back with the whole wheel size?
Like right here or right here?
More over there, yeah, is that like stock to hold on to? or-
Nope, this is a cutting operation through here.
So which part of the wheel runs on the track? That's what I'm trying to understand. And so this is not critical of your computer-aided manufacturing. I'm just trying to understand the design.
Curious about the design.
Yeah.
I believe typically the bevel is the part that's actually on the rail. So
Yeah, it just seems like a big angle. That's all.
yeah.
Okay. That I agree. It's usually bevel, but I didn't think it would be that much.
I didn't do that much research into training wheel
That's all right.
design.
The toolpath looks okay. So it looks like it'll work. It simulates okay. Doesn't crash or anything. Other than the tool comes from the wrong direction.
Great.
Yeah. These guys know how to fix that, right?
Yeah, so like, did you use the templates from one? I think you mentioned that you like started using the ST10 template.
Yeah, I didn't use the template at first, and I couldn't figure out why that was happening. And then someone just helped me basically reorient. I think it was Professor Bergstrom helped me reorient where the actual turret was, and they just said use the template in the future. So,
Oh,
okay.
never mind.
Yeah, fix your
Yours was the
problem.
group I taught that to, not group.
No, you taught it to both of us.
Oh, okay.
We did that yesterday.
Send out an announcement.
But yeah, so if you just start, if you open a spree and you just create a turning operation, you can totally do that. But what the software doesn't know is for the lathe that you're going to end up using, where is the turret in relation to where's the spindle? And so what you do is you go to the machine setup page and you give it some positive X value, and positive Z value for the turret location, and then it won't come from underneath and crash through the part to get to the cutting location. If you use one of our template files or start from, and if you go to the shared folder there and you go to Esprit data, you can go to M1800. I always start with the M1800 cylinder. And the reason I do that is because it has all of the tools that we normally have in the lathe already defined in the location where they normally are. And so it's just a habit for me. But you can start from scratch. It's not that hard to do. You just have to go to that machine setup page and tell it where the turret is. Go ahead.
Could you or Hayden post like an announcement on Canvas on how to access the template files?
Yeah, I can do that. Anybody else?
You might want to do like 5 seconds of research because I'm no train expert, but I've used model trains and I think that's just gonna like run itself off the train. Like I think it's usually like 15 to 30 degrees.
Good thing we're not making track.
Oh, you're not doing train.
So when you don't have a track, it's the not pointy part that's gonna roll on the ground, right? Physics says so.
Yes.
Right. You've been thinking if it was a trick question or not. So do you even need the pointy part?
If we're not using track,
That's why it's very aesthetic.
It's kind of like those big semi trucks that you drive by that have the little spikes that stick out. They're there to make you be scared. They want you to stay away from them. It's on purpose.
Does the idea to use those rubber wheels strapped? I remember that from the last presentation.
so at one point we did mention like rubber wheels, but we didn't feel like putting that part of our parts list.
You could also just add friction material to the outside diameter of this instead of a hanging.
Yeah. Rubberized coating. I know like cutting up an abrasive pad has worked for at least the roof robot project in the past.
All right. Group 4.
here. Good. Progress update for this week. This week we finished our end caps on the laser cutter. We started to machine our casing, and we finally finished our SolidWorks assembly that we've been semi-procrastinating on for a little while. Problems and challenges that we had this week. Some of the parts have like such a long process while being manufactured that we couldn't get them done in one sitting. We also need to ensure that our gears and screws mesh with the keyways that we still need to put into our SolidWorks. And once again, very long operation for the casing, so we could not get it finished for today. Our goals for next week are to finish our wire EDM toolpath, which I think we are very significantly through. To actually create one of our gears with that wire toolpath, and to start work on our screws. And the only thing that we really struggled with that we'd probably want a little bit more help on was running the actual EDM machine itself, not really the toolpaths anymore, but like the actual physical machine setup.
So I'll talk about the case a little bit. So we were in Washburn machining this. All we ended up doing was a facing operation, and we also ended up lopping off the end of it, but I'll talk about that in just a little bit. So ultimately, because the depth of cut is so large on this and we need such a long end mill, we're taking very short increments, which means that we have a really long tool path, and ultimately it's going to take a really long time on the mill. So we did a few things to trim that time down. We do have this split in half, so this is going to be made in two operations that are going to be bolted together. But like I said, we need a long end mill, so we're doing very small increments. The G code ended up being massive. When we went to transfer it over to the mill, there wasn't even enough memory, so we had to delete a few things. So we ended up just doing a facing operation. The stock that we have is, I think it was 12 inches long, so we ended up cutting 4 inches off. And that'll make the G code a little bit smaller, that'll make the whole machining operation a bit quicker to do, because there's so much less material that we have to remove. We have done a bit with the wire EDM toolpath. There are a few issues that we were running into with it. As you can see on here, the red line is cutting straight through the gear. Yeah, this was an issue that we were having. We fixed it. Obviously not what we want. We were initially having some issues with that. And also some issues with threading points. So I think ultimately this is going to be done in two operations, one to machine the shaft hole along with the keyway, and one to machine the teeth along the outside.
So for creating a toolpath for the wire EDM, first, like you have to bring in whatever solid model of the thing that you're going to make. To actually get it from being the 3D model to just kind of being flat with the toolpath around it, I don't actually know how to do that. We kind of had that part done for us, which is nice.
Save it as a DXF.
Well, okay.
Save one face as a DXF in order to import it.
So just save the face then. And then bring it into a spree. And then for creating the toolpath, you create the chain. Just make sure that you put, like, you can still auto chain. You just have to make sure you like start it at a spot where you actually want it to start. Because if the beginning of the chain is at the wrong spot, you kind of just have to redo the chain. At least that's what I found. So just try to get it right on the first one. Then switch to solid wire gold contouring to create the different toolpaths. So we had like an inside. We had internal hole and then also the outside edge because for the teeth. So we have two different types of contouring for that. You have dye for the internal holes and then punch for the outer edges, and then send it around. Make sure that the starting points for the toolpaths are at the right spot too, and then if the spree likes you and you do it right, then you end up with, you can have two different toolpaths and then it'll just move to the outside without cutting through your gear. So I hope you end up with that.
So what went right? Well, all 7 of us managed to actually meet in Washburn. Obviously, we completed the laser cutting of our end caps, operation of the casing, and now we got a lot more experience on the mini mill, so we'll be able to set it up a little bit faster next time when we go to produce the casing. And we really now understand how to use the wire EDM toolpaths, or how to make them. what we plan to do by next week. So we plan to complete our casing by next class, hopefully. As Nate mentioned, the facing operation is done, and the part has been cut closer to the size to reduce the time it would take to actually run the operation. We want to make some minor edits to the assembly to include the keyways that we've been talking about, and maybe some small aesthetic changes, but that doesn't really matter. And then we want to figure out the dimensions for our keyway and begin making the tool paths for our screws. Any suggestions, comments, or questions?
Are you gonna wire EDM the hole in the gear and then also the teeth on the outside?
Yeah, I think that was the plan.
Because could you just like wire EDM the teeth and then just nail the hole in the center of it?
We also want to make a keyway so that it'll transfer power to the shaft. Yep. Yeah, that's why we need to edit the model so it actually includes it.
We have keyway right in there, so
yeah.
When you were talking about choosing the right start point for your EDM chain, what exactly do you?
So when you're making, like, if you just do auto chain because you want to make basically the path that the tool is going to follow around the outside edge in our case, there was one point in our process where the tool path ended up being like, it ended up like the chain started somewhere down here, but like the beginning of the actual tool path was up here. So it like cut all the way through this to go down here. So if we wanted to move the beginning of the chain, which is hopefully where the operation should start, we just have to select the right point for starting the chain.
Okay.
That was all.
So in the advanced features toolbar, so there's like two toolbars that open up when you do the features thing. One of the icons there is an option to edit a chain, and you can move the start point. I have always found it to be easier to just create a new chain that has the start point where I want it. So I don't typically use that feature, but I do know that it exists, and people that like to use it all the time. But yeah, I always find it faster to simply create a new chain that starts at the location I want and goes in the direction I want, rather than try to remember how to use the edit chain feature, because I don't typically use it, so I have to go look up the help thing and then figure it out every time. And it's just like everything else that you do, and especially with software like Esprit, there are several different ways to get the same end result. There's not just one way to do it. Find a way that works for you and then just keep using it. You don't have to know all the different ways. And sometimes you'll see somebody do it differently from you and say, oh, in this circumstance, that way is better sometimes. But yeah, it is possible to move a start point for a chain.
Yeah.
I've always found it easier just to make a new chain.
Is your design coming from Mitsubishi? I just see that in like your feature tree.
Yeah, I don't know.
No, I pulled the assembly off of GrabCAD. I can't remember exactly who it was, but I don't believe it's from Mitsubishi.
I think it's actually assuming that it's a Mitsubishi EDM. It's not the it's yeah, because Mitsubishi makes EDMs, so I believe the software is thinking that it's a Mitsubishi EDM.
Any other questions or comments?
All right. So we're on group 7, right?
5, 4. 5 would be next.
Group 5. So group 7, that's when group 2 goes again. All right, group 5. So while she's logging in, yesterday you were in the lab and you were holding that piece, probably the same piece in your hand.
Yep.
And just next to it, you were holding a caliper in your other hand. I just, like, as I glanced at you when you were doing that, I thought you were holding our super long calipers.
Oh.
And you were like,
wait, super long
marking a mark
calipers.
on the piece of material with like a Sharpie or something. Or maybe it looked like you were. And I'm like, why the heck is he drawing on my $300 calipers?
Oh, no, I did not draw on the calipers,
But then I looked again and I realized it was two separate things. But that,
I didn't know there was an extra long set of calipers
yeah, we've got
in the lab.
We've got some.
Trying
So if you go back to it, it has a view and new tab right there.
Yeah, if you have view and new tab,
Yeah.
it's just
Oh.
So group 4, right? You guys had group 4's over here somewhere, right? You guys had some laser cut parts that you made this week.
Yeah, with the uncaps for the.
And you guys have some machine parts that you made, huh?
Yep.
So does that mean group 5 wins a prize?
Let it be.
Well, maybe. We'll see if they can actually present something to us. But so far, I think group 5 wins a prize for actually having made parts.
What do you need?
Did you machine
They were
parts?
made in a machine.
Okay. Yeah, you were gonna get the prize.
They were manufactured while being aided by a computer.
You were gonna get the prize for those, but I think their parts are cooler. We'll have a class vote at the end. All right, we'll vote at the end. See whose parts are better. What's that?
Group 4 is always the most people here on Monday.
That's true. You guys do deserve a prize for that. Good.
Trying to. Why did I ever set up two-factor on this thing? Of course.
I just put in you.
What I hate is when you have to do two-factor to get into your emails so that you can do the two-factor for the thing you were actually trying to log into.
Exactly. Yeah, it's
I have nothing for anybody to see.
Can I do it? Yes, of course it is.
Well, like you need two-factor authentication to get into Canvas.
That is the
After
most
you're already
frustrating
logged
thing.
into the computer. Yeah. And that bugs me because, I mean, really, is a hacker gonna log into Canvas and edit my class? Gonna do my homework?
There we go.
And if it really, if you
No.
need it really so badly that they're gonna hack into the professor's computer to change your grade, you deserve it.
That's why you should go to computer science.
Why is this being difficult? All right.
So we're saying we saved the best for last, right?
I mean, we have the parts, so
We
isn't
do.
it?
Yep.
Do they
Yep,
fit
parts
together?
presentable.
They don't actually go together, but like they can just kind of sit in here.
There
But
are two of them.
yeah, there's two of them. They don't go together in the actual puzzle, but they fit.
Oh, well, that makes the puzzle harder.
It makes the puzzle harder.
Right, because if two pieces, if the pieces never fit together except when they're correct, then the puzzle's easier. If there's more than one way to fit the pieces together, but only one way is correct, that makes the puzzle harder. So that's good. All right, go.
I don't think it's good for us, but us who needs to get the puzzle together. All right, we're group 5, the puzzle group. I'm Lily.
I'm Tyson.
So for this week's progress, we found stock material. We tried to at least finish the cam for one of our parts. I know some people got a little bit ahead, but for a lot of us, we had to refresh ourselves. So we started the cam. We started machining parts, as you can see. And then our goals for next week is to finish all of the cam and all of the milling. So either, finishing the cam for our last part, milling all of the parts that we have, finalizing that so that we can start wire EDMing, and also just general fit test, so tolerance test. Can these parts actually fit together and make the puzzle, or is it going to end up like our 3D printed one where it got stuck and we can't move it anymore?
Hopefully machine one's better.
Hopefully. So some problems.
Go ahead.
So some problems in eSprit, we had problems configuring our parts. So like getting the stock material to line up with our actual part that we imported from SolidWorks, that was a learning curve. Having some rough edges on parts, and just trying to find the stock for some of our larger parts on the cube. So we have some parts that are, I think, like, is it 3 inches? The big one?
I think so.
Which is definitely going to be hard to find a stock piece that's that big that we can use. And then some assistance. Ours is just, if we have any more questions on CAM, we'll need assistance with that. And otherwise, it's just being able to mill all the parts.
And also finding, the best finishes we can use for any of the parts that we make. So looking at this setup, we took a look at, trying to figure out the best way to set these up, and we figured that it would be best to go with the origins made from SolidWorks and then open them in Esprit. So moving forward, we moved on to making cam operations for part 2. Follows, it was set up on a in a stock in Esprit. As seen here, it shows that it goes through quite a few operations. First operation is mainly just to get the right shape. The second operation just cuts the whole thing off through what looks like a facing operation. Is that correct? Yes, okay. For facing operation, let's see, part 7. That's actually one of the parts that is already finished right here. So a milling operation, then 2 more, still has 2 more operations needed, but so far, already good at getting somewhere. And this is part 2, already milled out and, finished. Let's see, moving right along. Then also working on the cam for some of the other parts. For example, part 8, this one used a few different facing operations, didn't really go for any contouring, mainly to maintain the sharp edges through the process. And so far the simulations are looking good. We hope to do some actual machining of these parts later on.
So now for the tool paths, it did take some of us a bit to learn how to use it. So this is one that is relatively done for the tool path. The simulation turns out okay. So this is what the finished part will look like. And then this is one that I was doing. I have a staircase, and I started on tooling paths, and it did this, which is clearly not what we want. So that's one of the challenges, just one of them that we've had in the group in trying to get our tooling paths correct. And then finally is the machine part. So we brought them in, but these are the 2 that we have so far.
And currently we're still trying to go about the best way to finish these parts. Yeah, I guess that would do it for our presentation this week. Any comments, questions?
How many parts are you guys making?
13?
13 technically, I think 16 or 17 based on duplicates.
Do you guys have a backup plan in case the tolerances don't quite work out?
We're probably going to have to go back to edit the model and add some higher clearances and make sure they all don't add up to failure.
You could Also get a bigger hammer.
Or that. Or we could use files, but that's technically handwork, so I'm trying to avoid that.
Anybody else?
So I actually have a question. So when you've been in the lab working and you had us 3 questions, how hard was it to find someone to answer the questions?
So I've actually been in the lab with Nick most nights.
Okay, so you know Nick, and
So,
you know he knows
yeah, I
the
know
answers to the
Nick,
questions. Got
and
it.
he's been helping me.
How about the rest of the class? When you've been in there working on a spree and you have a question, how hard has it been? And I'm asking this because I want to try to make it easier, but I'm trying to understand what the process is. So is it always obvious who can answer your questions, or do you have to search around? Some of you say it's obvious. Some of you say you have to search around. Yeah, what do you got?
Well, because since Nick is in our group, that was kind of like a benefit and kind of nice to have. But like, if I didn't have Nick, I think I wouldn't know if some people are there for ME1800 and not wanting to help us or not.
So I was thinking about that because I guess I haven't been there in a long time, but if you go to like HL230 or the other design lab at Higgins, there's always like a PLA or somebody there, but they always sit at a desk with like a label, right? So you know who to go ask when you have a question. And I've been thinking about maybe we should get like a different color lab coat or something in. So when you're the person who's on duty, because we actually right now have somebody there from 10 to 5 every day and from 10 to like 9 p.m. 2 or 3 days a week. So there's supposed to always be somebody there to help, and they're there. Sometimes they're helping M1800 students, but they're really there to help anybody that has questions. And so I'm just wondering if we need to do something so that those people are identifiable to the general public that walks in. Seems like the consensus is, unless you already know somebody, then yes.
Yeah, that would be very helpful.
Yeah, all right, so, I don't know, what do you think we should do? Make them all dye their hair pink? With me, I would have to get like pink makeup or something, right? I'd get a tattoo.
You could just tattoo your whole scalp.
Oh,
Just
you
get a
can
pink
do a
wig.
tattoo on the forehead?
Lab.
There's something really tall. Something tall, like a dunce cap.
No,
Yeah. Top hat. I like top hat, or maybe a bow tie. If they've got a bow tie on, you can identify them as the
Right,
style.
safety.
I'm not feeling this dress when I go talk. All right, we'll come up with something to. I'm guessing, and it probably won't help you guys because we'll have to order it and it won't come in. But maybe we'll have them all like wear a piece of blue tape or something on their shirt. And work. Just blue tape with PLA written on it. Put it on their shirt. But I think what we'll do is we'll get like lab coats and that say staff on the back or something, and then they wear them when they're working. But yeah, I was realizing when people have come to ask me questions, and I know that there's a lot of other people there that can answer the questions, but how would you know who to ask? That dawned on me yesterday when I was working with one of the groups. So we'll see what we can do to make it easier to identify the people that are actually getting paid to be there to help you.
For robotics, we have 3D printed tags, which is something that you can get really quickly.
Well, we actually just got some materials to make name tags. Maybe once we get those name tags, it'll work. But they're pretty subtle. They're like black aluminum things with an engraving on them.
Ours are bright red, so.
So, yeah, I think bright red would have been better color. But I still think like a fluorescent dunce cap. We can do that. But I think we can do that. You just go to the craft store and you get some craft paper and you roll it in a cone and tape it. We could totally do that. Or make everybody make their own hat out of duct tape. Right? You make it a challenge. You guys are done?
Yeah.
Any questions for the group? And I guess you guys partially machined apart too, right?
Yeah, started.
You just didn't bring it with you because it was big and heavy.
Yeah, and
there's really not much to look at.
Really heavy.
It's still kind of very heavy
Just a
Slightly
small,
different.
it looks like a small rectangle. So I guess maybe you're on par because they only finished one part. You guys finished, yeah, I don't know. Finished whole. Which, you guys can sit, unless you want to stay standing, it's up to you. I have a question though.
Yeah. My question.
Oh, and if somebody from your group 5, somebody from your group could come by during the day tomorrow on Friday and find me, and we'll find the stock material you need. Because you need a couple of larger pieces. I'm sure I know where they're hidden behind something, under something. I'm not going to extend out to go the whole time today, but since we got a large majority of the class here, would you guys like to meet in the lab on Monday instead of in the classroom?
Yeah.
Now, the problem is 30 of you coming to the lab all at the same time is going to be crowded because the room that's got computers in it has like 16 computers. But if you take 30 and divide it by 2, it's close to 16. So we could do shifts. Who could like stay late? Who doesn't have anything right after this? If you came a little bit later and stayed later until like noon or what? Oh wait, can I stay late? Monday I can stay late because like today I have class immediately after this. So if we'll do a sign up, maybe.
I don't know what that is.
It's my phone because I log in to make sure that the YouTube thing actually has audio. So you'll notice at the beginning of class, I stick my ear thing in for a minute. Group 1 might notice that. Looks like I'm jamming to the tunes when you guys are talking. It's actually I'm making sure I can hear you guys because I've done it. Some of you may have been in the class. It happened within the last 4 years. Maybe it didn't. Maybe it was longer than 4 years ago. They all blend together now. But I was in the classroom, and it was the lean manufacturing lecture in ME3820. And it was when I used to do the lean manufacturing lecture on the second day of class. And I was super excited about it. And I did the best lecture of my life. Like, you ever feel like you've done something well? Like, I was so pumped at the end of that. A student came up to me at the end of class and said, for my summer job, this is what I did all day long. Like, I worked in a group that was about implementing lean manufacturing. And this is the best description I've ever heard of what lean manufacturing is. Like, the student says that to me at the end of class. I was pumped. It was the best lecture ever. Went to watch the video. Mic not turned on. So it was a great video of me running around the classroom and talking, but mic not turned on. Waste of time. Should have just stayed in bed that day. What we'll do is we'll do a sign up. So worst case, we could do half of you come for the first hour and half of you for the second hour. I think I might like to go a little bit longer than an hour so that we could actually sit there, go through some stuff in a spree together, and can be working on it. You could actually be working on your parts and asking questions, and then I could raise points and talk about that. I think that might be useful for the class. Is that good for you guys? If we meet in Washburn next week instead of in this classroom, and we'll do maybe do like a Google Doc to see who could come, who could stay late. If we get volunteers to stay late, does that make sense? Post a link to a Google Doc. Yeah. And so if you'd rather start at 10 or start at 10:30 and go to 12 or something like that instead of starting at 9 and going to like 10:30, is that 10:30 to 12 is the right? Yeah, 10:30 to 11 would be a half hour. Yeah, that works. Yeah.
9 o'clock still works.
Yeah, we could do like yeah. I'm just saying maybe some people would rather come to a later session if they have time, and so we'll put that out there as an option. And if only 3 people select the later section, then we'll just do like 9 to 10 and 10 to 11. But if half of you want to do like 10:30 to 12, then that works out. I can just be there all the time. Anything else? Any other questions for me? I have some general feedback for you guys. 2 groups were outstanding today. Who knows which 2 they were? 2, or maybe not outstanding. 2 groups stood out to me today. Yeah.
Ones with parts.
So the ones with parts, yes, but that's a coincidence.
I was going to say that I thought group 4 did.
I thought group 4 did really well today until I saw group 5. And then I was like, wow, both group 4 and group 5 did really well today. And you might think it's because they brought in parts. And that certainly helped make me notice. That's not the reason I think they stood out. Yeah.
They went through the process of which piece kind of detailed how it turns out.
Sort of. I think group 1, I think group 1 did a really good job at that, talking about their thing. And I actually, the video simulation group 1 gave us a really good in-class discussion about those things. So anybody else got a reason why those 2 groups stood out for me?
The first slide.
Because they both used the first slide in the format that I had asked you guys to use. And other groups talked about all the things, but didn't have that first slide up there. But groups 4 and group 5, thank you for using that format for your first slide. And thanks for making parts and bringing the parts. Group 1, thank you for your exciting video and all the talking points. And group 1 is the only group that took up all of the allotted time. Group 2 was finished in 7 minutes. 7 minutes. I looked, I checked my watch, and that's 7 minutes from when group 1 finished until group 2 was finished. So you were what? Concise, precise, right?
Precision.
Anyways, I thank you guys for being here. Let us go early. If you're still working on stock material and making sure you have the stock material you need, somebody from the group come find me tomorrow in the lab. Don't bother me today. Today's a busy day, but come find me tomorrow in the lab, and we'll make sure that we have all your stock material either on hand or ordered. Yeah, you have a question?
Well, after you're done announcing, I had a request of the class to help me with signatures for a plug, but that's
okay.
Unrelated. And after you're done talking.
When I'm done talking, sign whatever she has. Right? Where's bonus? So which group was the best though? Was it group 4 or 5?
2.
Group
1. Group 5.
All right. So we'll quickly vote. Group 5. Control screen up. All right. So 1, 2, 3, 4, 5. Now I would love to do the applausometer, but there is another class on the other side of the wall. So, and you can vote more than once, I suppose. So, who votes for group 1? 1, 2, 3, 4. 5.
Don't forget this arm.
Said you could vote more than once.
Oh, wait. Fair enough.
Group 5. Who votes for group 5? Out of order, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Why you would vote for them?
Who votes for group 3? End card. Group 3. 1, 2, 3, 4, 5. Are you voting? You weren't voting. You were showing. 5. Which group is that? 3?
That's 3. You can add that to 1.
Group 2.
Let's go.
1, 2, 3, 4, 5, 6, 7, 8,
I like theirs.
9.
I like that one.
Go 5.
Which group is that?
In group 4.
Oh, you're right.
Group 4.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. So what is all right? What does Group 4 get for a prize?
They get to go first next week.
I like that. Group 4 goes first next week.
Good idea. Let's go.
All right. Hey, thanks, guys, and I'll see you Monday in Washburn Shops.
I need.
But sign her thing.
Yeah. If you have any